Welcome to presentation 5 in this mini video series where we are going to discuss how we think critically about evidence. In this mini presentation we're going to focus on relevant evidence, representative evidence, looking at variables. We'll touch upon correlation and causation once again, and we'll look at the quality of evidence. Now, using relevant evidence, what we would like our evidence to do is to support the conclusions that we make in our writing and in our research. Irrelevant evidence might be relevant to the subject but not to the conclusion, and is relevant neither to the conclusion nor the subject. And you can try to avoid these types of evidence in the planning of your assignment. Now, using relevant evidence, we've got a statement here and it's similar across all three slides. So firstly, you've got the opening. So people need to improve their understanding of how language works so they can use it more effectively. Then we have the evidence in the blue box. Research studies show that the study of foreign language improves our understanding of the structure of language. Therefore, people who only speak one language should be encouraged to study a second language. And that evidence is relevant, because if the goal is to understand how language works, then learning a foreign language improves our understanding of the structure of language, and thus that then supports the conclusion. Now, the first and third statements, so the opening premise and the last conclusion here, is exactly the same as before, but the evidence says research studies show that many people cannot describe the different components of their own language. And then we move on to the same conclusion. People who only speak one language should be encouraged to study a second language. However, the evidence does not support that learning a second language will help you understand the components of your own language. Thus, irrelevant evidence. Then we have our third and final example, where again the opening premise is the same and the conclusion is the same. However, the evidence says research studies show people can recognize concepts in a foreign language even when there is no word for that concept in their language. However, that evidence does not link, once again, to the conclusion. So just some examples there of evidence that fits with the first premise and the conclusion, and two examples where the evidence does not. And you want to try to avoid these situations in your writing. Using relevant evidence. When evaluating an argument, check that the evidence is relevant to the topic. It is needed to substantiate the reasoning. Does it make a difference to the conclusion? If so, does it support or contradict? Because there are going to be some examples or times when you're not just going to provide evidence for one side of the argument, so some evidence might contradict and some evidence might support. Is the evidence needed to substantiate the interim conclusions? Now, using representative evidence means that you're assessing, or the studies you're reading are assessing, the demographic that they're making conclusions for. So, for example, here you can see that there is a combination of demographics, which is shown by the difference in colours in these people. And if you just assess the purple, dark purple, the light purple and the dark green, then you're not getting a full representation of that population, and thus the conclusions you make can only be directed to the demographic that you're using in that study. So, what sample is used? How big is the sample? Is the sample varied enough to make far-reaching conclusions? Does it reflect the population that you are wanting to research? And how is that sample collected? And you can see here from the pictures at the bottom that the demographic that would be assessed is just the light and the dark purples. So any conclusions made from this research would not be able to include the green and the blue individuals on the left-hand side. Now, using representative evidence. So this example, 4 animal charities wish to know the views of the public on whether pets taken overseas should be held in quarantine before being allowed to re-enter the country. Now, using a representative sample or representative evidence. So sample 1, you've got 1,000 dog owners from across the nation with roughly equal numbers from each location. Sample 2, 1,000 dog owners from across the country. The sample was balanced to ensure more people were surveyed from areas with high populations. Sample 3, 1,000 pet owners with a range of pets, including guinea pigs, cats and dogs. And the final one, sample 4, 1,000 people with and without pets from across the country. The sample was balanced to ensure more people were surveyed from areas with high populations. Now, from those 4 examples, the most representative sample would be the last one. And the reason for that is because all of the previous samples are people who just have pets. So the first one is dog owners, second one again just dog owners, the third one a mixture of pets. So all of the answers in those could potentially be biased answers. The final sample not only has a mix of individuals with and without pets, but it also has a balanced amount of people where they were surveyed from areas with high populations. Now, when is a smaller sample okay? Is it a question of health and safety? Do all backgrounds and or characteristics need to be represented? How much funding is available? For example, in studies that assess microbiome, the assessment of that, transcriptomics or metabolomics can be quite costly, and thus it will put an upper limit on the amount of individuals you can recruit for that study. Is a large sample practical? And how detailed is the data? So these are the types of questions that you should ask yourself when you're reading papers that may have a small sample size. And it's not the fact that those small sample sizes are not good studies. It just means that the conclusions that are made can just not be far-reaching to lots of different demographics. They're very specified in the knowledge and information that you can actually get from that sample and that sample size. A task here for you to complete on using representative evidence. Open the handout called Sex Differences Abstract and read the text from a journal article. This is available in the module materials, and think about answering the following questions. Are the samples representative? And will they collect the data needed to answer the question? So, how much control do you have? A case is the topic of study. This can be anything, for example, a person, an animal, a plant, or a chemical. A characteristic is a feature of the case. Any characteristic which can vary is called a variable. For example, this might be the height of the plant or the weight of a person. When studying a group of students, for example, variables might include their age, height, gender, hair color, the number of languages they speak, or the subject they are studying. Now, when we're thinking of data as well, you want to be able to try and use triangulation, which is finding corroborating sources which can help improve the quality of your evidence. So, what other pieces of evidence would help corroborate the examples on the handout? Now, triangulation is something that facilitates the validation of data through cross-verification from more than two sources. And in a way, when you synthesize research and you find more than 2 or 3 papers that all say the same thing, you're finding corroborating evidence to back up a statement that you're making in your research or your writing. And it's really important to do this where possible. So we've touched upon fallacies before and correlation and causation. We've seen this slide previously where ice cream sales are compared to crime rates and they both go up and down and are potentially correlated. Again, another example, is of correlation and causation is per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets, and divorce rate in Maine correlates with per capita consumption of margarine. However, does this really signify causation? And these are the things you want to be thinking of when you're reading papers that are looking at correlations. Now, is there a third factor there that could be suggesting why both of these variables are moving in the same direction? Advantage, but not cause? Are they entwined, so cause and effect? You want to ask that question. Could it be just by pure chance? Is there some kind of statistical manipulation? And is the cause and effect that you're looking at confusing? Is there no reason for it? Now, can you think of any occasions recently where someone has made an unsupported assumption about causation? Was there a more reasonable explanation? And lastly, I'd just like to show you the hierarchy of evidence. So an image that we've got here on the right hand side. Now you can see that the quality of evidence is lower the further you go down the pyramid and higher as you come up, and the risk of bias decreases as you come up through that pyramid. And at the bottom you've got editorials and expert opinion, and at the top we have randomized controlled trials and then systematic reviews and meta-analyses of randomized controlled trials.